What's good, guys? Welcome back to another video. Today I had a student ask me about linear speed. Has a couple questions on our homework, kind of going over this. So today we're going to be going over what linear speed is, angular speed, all of those things, and essentially how do we apply these to math-based questions. So without further ado, let's get right to it. All right, first things first. What is linear speed? Well, linear speed, should I say L, is equal to angular speed, which is usually shown as W, times radius. Now you're asking me, what is angular speed? Well, let's go through all these. Angular speed is basically how fast the angle of something is changing. In other words, if I'm trying to take it out of this math context, it's rotations, right? Rotations per minute. So if you look at like a circle, for example, and I'm starting here, and then all of a sudden I'm here, but then next moment I'm here. See how I'm just measuring the distance and the angles in between here? Just like that. That is what angular speed is. Now my R value is my radius. Now why does radius matter? Well, the size of the tire matters, right? If it's a bigger tire going at the same pace as a smaller tire, well, your linear speed, in other words, how much you're traveling in a straight line, is going to be faster because that rotation is bringing you farther. So if we take the angular speed, multiply it by the radius of the tire, it's going to give us our linear speed, which is essentially what we're solving for today. Anytime we're dealing with linear speed, this is a very circle-based trigonometric idea, and you'll see that in these types of questions. So without further ado, let's get to those questions. All right, guys, question 1 reads like this. If a wheel with a 16-inch diameter is turning at 12 revolutions per second, what is the linear speed of a point on its rim in feet per minute? All right, so first thing I'm gonna do is I'm gonna draw everything that we got. We know that our diameter, in this case, is equal to 16 inches. The next thing that we're told here is that it's 12 revolutions per minute. And we're trying to find our linear speed in feet per minute. Well, first thing I'm gonna do is I'm actually gonna find the circumference here. Now, why am I gonna find the circumference? You're probably sitting there like, Jaden, I thought you said it was angular speed times radius. Well, that is true. And if I wanted to, I could change revolutions into angular speed. What are revolutions? Think about this in this case. Revolutions are a full rotation around. So it is what angular speed is. It's just not in radians. Angular speed's in radians because it's dealing with the measure. This is just saying one full rotation. So like that. But if I'm doing one full rotation, but I'm pushing it forward, notice what I'm doing is I'm basically just unraveling my circumference. So in other words, if I find the circumference of this tire and then show that these revolutions are happening 12 times every minute, it's like I'm taking the tire and I'm pushing it down so then it flattens out. So the way that I can solve this is I'm gonna change my diameter into circumference. Circumference is pi times diameter. So in this case, 16 pi times my revolutions per minute, which is equal to 192 y inches per minute, pi. But the problem is that they don't want it in inches, they want it in feet. So now what I have to do is I have to convert it. Well, how am I going to convert it? What I'm going to do is divide by 12. Well, I'm dividing by 12 because feet are a bigger metric than inches. There's 12 inches in a foot. So every 12 inches is representative of 1 foot, so your number you would think for feet is going to be smaller than inches, which is the reason why I'm going to divide this thing by 12. 12 goes into 19 one time with 7 remaining. 12 goes into 72 6 times. So 16 pi feet per minute would then be our linear speed. Problem 1 complete. All right, next one. The crankshaft pulley of a car has a radius of 10.5 centimeters and turns at 6 pi radians per second. What is the linear speed of the pulley? All right. Okay, for this question, we're given 2 things. We're given the radius. In this case, radius is equal to 10.5 centimeters. Chill. And the next thing that we're given is it turns at 6. That's right. It is Angular speed times radians. Well, radians per second, that is angular speed, right? This is in degrees basically, right? We're in radians now. So what was that linear speed formula I said? So in this case, all this is 10.5 times 6. Now we can do this in our head. 10.5 times 6 is the same thing as 105 times 6. 5 times 6 is 30, carry the 3. 6 times 0 is 0 plus 3 is 3. 1 times 6 is 6. So 6, 3, 0. One number behind the decimal in the question, so one number behind the decimal in the answer. So 63, in this case, centimeters per second. We're all done. Next question says, find to the nearest centimeter per second the linear speed of a point on the rim of a wheel of radius 24 centimeters, turning at an angular speed of 17 pi over 12 radians per second. Again, we're given the radius is equal to 24 centimeters. We're given radians per second of 7 over 12 pi. Right. Similar to the last question, I'm given radius, I'm given the angular speed. I just multiply these things together. So 24 times 7 over 12 pi. I'm noticing right here, these are going to reduce. 12 goes into itself one time, 12 goes into 24 two times. 2 times 7 is equal to 14 pi. And then in this case, centimeters per second. And it wanted it to the nearest centimeter per second, so what you would do here is you'd multiply 14 times pi, and then you would basically get that final answer there. But that's the exact answer. We'll just leave it just like that. All right, guys, 2 more. So the linear speed of a point 15.3 centimeters from the center of a phonograph record is 17 pi centimeters per second. What is the angular speed of the record in radians per second? Whoa, this one's a little bit different. The reason why this one's different is because we've been given linear speed. So linear speed, which is actually typically shown as v, so I'll just start doing that right now, is 17 pi centimeters per second. The other thing that they give us is radius. So the radius is equal to 15.3 centimeters. And we're asked to find the angular speed. Well, in this case, what I want to do is I'm just going to plug everything into that equation I've been doing. It's just now that I've been given my linear speed value, it's going to be 17 pi is equal to 15.3 times W. Well, inverse operations, how do I solve this? Well, 15.3 is multiplying by W, so the opposite in this case is divide. So at the end of this, I'm going to get W is equal to 3.49 radians per second. That'll be it. All right, last question here. Find the coordinates of the final position of P moving counterclockwise in the uniform circular motion at W equals pi over 3 radians per second if P starts at the point 50 and moves for 14 seconds. Wow. Okay. So let's kind of go through everything here. So first thing is first, I'm told that W is equal to pi over 3 radians per second. Okay, next thing is P is at 5, 0. And we're trying to find a new point when, or let me not say when, let me just say after 14 seconds. Okay, well the first thing I'm noticing is that It's after 14 seconds. Well, angular speed is radians per second. So what I can do is I can multiply pi over 3, which is radians per 1 second, by 14 to get radians, or the angular speed in 14 seconds. Well, that is just going to give me 14 pi over 3. Okay? But this angle is pretty just like redundant in the sense that, remember, the unit circle is only just 2 pi radians. I don't need all of this. So to find my like reference angle, in a sense, what I'm going to do is I'm going to subtract 12 pi over 3. In other words, why I just subtracted is 4 pi. In other words, 2 full rotations around the circle. So that would give me 2 pi over 3, which is in fact our exact placement on the graph. Okay, so now the next part about this is something that we're going to have to kind of identify with the unit circle. So, side quest. Unit circle looks like this, and if I have a point, let's say it's right here, this part right here is my x value, this part right here is my y value, and typically we say that the hypotenuse of this thing is right r value. So, what is cosine and sine? Well, cosine is adjacent over hypotenuse. So in other words, in this case, cosine of theta, right, this angle right here, is equal to the adjacent x over the hypotenuse r. Well, this thing is asking for the coordinate. So in other words, it's the x and y value. So what if I multiply both sides times r? Well, now I am told that x is equal to x is equal to r cosine theta. Well, let me do the same thing with sine. R sine of theta is now equal to y for the same exact reason. And so essentially why I'm saying this is because if I can plug both of these points in, well, that's going to give me my answer. Well, r is the radius, and if you think about this, this is the x-intercept, which is essentially, in this case, going to be our radius right there, but not right there, it's right here, right? Because this is the x-intercept right here at 5. So I'm just going to plug that in. So in this case instead, I'm going to get 5 cosine of 2 pi over 3 and 5 sine of 2 pi over 3. Well, now here comes some trig stuff right here. 2 pi over 3, the reference angle is pi over 3, which in this case is 60 degrees. The way that I remember the unit circle is 3, 2, 1, 1, 2, 3. So in this case, 60 degrees is going to be all the way up the top. So for cosine, 3, 2, 1. So in other words, 5 times 1/2. Now 2 pi over 3, that's 360 divided by 3. In other words, 120 degrees. Second quadrant, cosine's negative. So this is actually going to be negative. So in this case, negative 5/2. Now 2 pi over 3, if cosine's 1/2, sine is going to be root 3 over 2. Sine is still positive though, but then we're going to multiply it by 5. 5 times root 3 over 2, giving us our final coordinate. And there you have it, folks. That's it for today. All these things about linear speed, we got a little trig in there as well, and we're all set. So I hope you guys enjoyed. If you want content done like this, similar with questions that you have, drop them down in the comments. If you enjoy content like this, you want me to keep on making some questions about homework, study guides, all that type of stuff, feel free to like, comment, subscribe. All those things are chill with me. But until then, I'll see you on the next one. Take care, and as always, peace out.